Hello friends, in this video we will learn everything about why container. You know what, before that let's go back to our story that I had started in my last video on Docker image. So remember Mr. John, the developer? He was working on an application which was built using multiple softwares, dependencies and configurations, right? Since he is done with his development, he created an image of the application with all its dependencies and then given it to ops team for deployment. That makes ops team's job pretty easy, right? Because that way he does not need to bother about simulating the development environment by installing all the required software in the production server. Now the question is, how does ops team runs the application using this image? So in Docker environment, ops team basically creates an isolated environment. Important is the environment is created in just a couple of seconds, puts the application in it and runs it. So the application runs in completely isolated environment. Friends, welcome to the world of container. This isolated environment is nothing but a container. Let's see what we are going to discuss over next 15 minutes. We will try to understand what problem container solves. While looking into this, we will also understand the benefits that container provides us. We will see the difference between virtual machine and Docker containers. In the process of learning this, we will learn Docker commands related to container and how to run images in a container. On high level, I have already explained this topic in my video on getting started with Docker in 50 minutes. You can find the link in the description. In this video, we will go a little deeper into it. So let's get started. So as discussed in intro, we run our application inside a container, right? Now the question is, why do we want to do that in first place? Let's look at some prominent reasons for using container. Let's begin with what problem container solves. If you are a developer or a tester, you must have come across this phrase, it works in my machine but does not work on another machine. Have you ever said that? Please do comment and let me know. By the way, recently got this image in WhatsApp. It says, it works in my machine, and the other guy says, then we will ship your machine, and that's how the Docker was born. Kind of funny, but could be this was really a reason why container came into picture. Container helps software to run reliably when moved from one computing environment to another. What do we understand with this with respect to container? Let's see that. So let's say a developer develops an application in this dev system and it runs perfectly in this system where it is developed. Now the developer wants the application to be tested by the tester, so he deploys it to the testing machine. But guess what? The application does not run there. It's the same code base, but still it does not work. Remember, it works in my machine phrase? The reason why it does not work could be the platform version does not match. Say the developer has developed the application in .NET 3.0 and the testing machine has 4.0, and because of that you get some weird error. This could be even operating system mismatch or some config files update missed, or there could be n number of other reasons. Now, how can you solve this using container? Remember Docker image? You will create an image. Now, as you know, images are the application bundled with all its dependencies. So, this image will contain all its dependencies, including operating system. Now, instead of deploying the source code in the test machine, you will basically send this image to the test machine. Now, the big question is, how does test machine run the application which is inside an image? That is where the container comes into picture. In the test machine, we will spin up a container and run the application inside an isolated environment. This container consists of entire runtime environment, including the application plus all its dependencies, libraries, other binaries, and configuration files needed to run the application. You can even send the same image to staging environment or to production environment. It will work all the same. Only required condition is all this environment should have Docker installed. In real-time environment, how do you share these images? Remember Docker Hub, the image repository? You generally push it to Docker Hub, and anyone who wants to run the application will pull it to their environment, spin up a container, and run the application in it. And the application runs exactly same the way it was running in the development environment. Let's see a demo how we can pull an image from the Docker Hub and run it. Let's open a browser and go to hub.docker.com. Let me zoom it a bit. So this is the image that I would like to pull it and run it in a container. This application was built in a different system. Let me copy this image name. Let's jump into our command prompt and pull this image. At first, let's see if we have any images here. So we do not have any image. Let's pull our Node.js image. Docker pull image name. So image pulling started. Pulling completed. Let's see if we have the image now. So we have the image locally now. Let's run it in a container. So to run an image in a container, just type docker run -d to run it in a detached mode. Let's do a port mapping, map 9000 to 3000, which is basically the port exposed from the application, and finally our image name. So our container is started. Let's verify that. To verify that, just type docker ps. So our container is up for 10 seconds. Let's jump into our browser and run the application. So localhost, remember the port number that we have mapped? It's 9000. Boom! Our application is up in the browser. This is just a simple static page with an image. Let's go and stop the container. To stop the container, type docker stop, few characters of container ID. Let's see if our container is stopped. So no containers are running. Let's see the stopped container. For that, type docker ps-a. So our container is in exited state. Let's go and refresh our browser now. See, the application is not available anymore. If we want to make our application up, run it back in the container. Let's do that. So our container is running. Let's go and refresh our URL. See, the application is up again. So it solves the problem of portability, and together with it, it solves the issue of works only on my machine problem. Apparently, what we just saw also demonstrates how fast it is to spin up a container, which ultimately saves time. Now team does not need to spend huge time in configuring the system to make the application work. As we have seen that containers are very portable, self-contained, and have all the dependencies packaged in it to run. They are less dependent on the specific server environments and configurations. In other words, this means that your application is almost decoupled with the host environment, which implies you can save time on configuring your system with the application dependencies, environment variables, etc. Let's discuss one more point on why container. Docker container enables more efficient use of system resources. Let's compare it with virtual machine to understand this. So how does a virtual machine works? You have a machine, could be a desktop, laptop, or a machine in the cloud. On top of that, we install an operating system. Normally, you run your application directly on these operating systems, but in case of virtual machine, you have a hypervisor here, which creates and manages the virtual machine. On top of that, you create your virtual machine with a guest operating system and dedicated shared resources from the host machine. It means if you want to run 3 applications, then you would spin up 3 virtual machines and run your applications in these 3 different virtual machines. But one of the waste here is this each virtual machine requires its own operating system, which consumes a lot of space. Let's take an example. Say you have an application and you need 10 GB RAM to run it. So as of now, your RAM requirement is 10 GB. But since you will be running this application in a virtual machine, you definitely need a guest operating system. Let's say the operating system takes 5 GB RAM. So now total RAM requirement becomes 15 GB. Now what if you have 10 such applications? So 100 GB RAM for the applications. And oh yes, for operating system we need additional 50 GB. It means you are using 50 GB of your disk space only for guest operating system. And that becomes even worse because each guest operating system also needs its own CPU and memory resources too, right? Hence, there is a lot of waste happening here, right? Similar costs will be there for licenses for the softwares like could be licenses for operating system and other dependent softwares. Additionally, lot of maintenance cost on these VMs as well. So we realize that there are a lot of wastage of resources. Let's see how Docker container works. We still have some kind of hardware, a laptop or a desktop or even a VM. Then similar to VM, we need a host operating system. But on top of that, we do not install hypervisor now. We install Docker, in which we have something called Docker engine that basically replaces the hypervisor. Now, this Docker engine manages everything that is required to interact with our container. And on top of this Docker engine, we spin up our container and run our applications in it in isolation. Now we do not need additional host operating system, and also containers can be as small as 10 MB. Hence, it saves a lot of space. I hope you have realized why we are moving towards the world of container. That's all for today. I will create a dedicated video on all the container related commands. Please do subscribe the channel for all the upcoming videos on containerization and C# programming. Thanks.